Welcome to Study Loop.
Hello students, for the first question we have to calculate the width of the belt required. Given that the power is 30 kilowatt, which is equal to 30 into 10 power 3 watt, and the diameter is 1.5 meter and the speed is 300 rpm. The angle of contact theta is 11 by 24. So converting it into degrees, this will give 165 degree. So this will be equal to 165 into pi by 180. This will give 2.88 radians, and the coefficient of friction on the pulley surface is 0.3, and T is equal to, that is thickness is 9.5 millimeter. This is equal to 0.0095 meter. Density is given as 1100 kilogram per meter cube, and the stress is given as sigma 2.5 megapascal, which is equal to 2.5 into 10 power 6 Newton per meter square. So now let T1 be the tension in tight string side of the belt and T2 be the tension in slack side of the belt. Now we can calculate the velocity of the belt. So velocity, which is V, is equal to pi dn by 60. So this will be equal to pi into d is 1.5 into 300 divided by 60. So this will be equal to 23.57 meter per second. And next we have to calculate the power transmitted. So this is power transmitted is 30 kilowatt. This will be equal to T1 minus T2 into V, which is the speed. So T1 minus T2 into speed we can write as 23.57. So we get T1 minus T2 is equal to 30 into 10 power 3 divided by 23.57. This will give 1273 Newton. This, let it be the equation 1. And now we know that 2.3 into log of T1 by T2 is equal to mu into theta, which is equal to mu is 0.3 into theta is 2.88 is equal to 0.864. So now we get log T1 by T2 is equal to 0.3756, or we get T1 by T2 is equal to 2.375. Let it be equation 2. That is, here taking anti-log we get this value. So from equation 1 and 2 we can find T1 is equal to 2199 Newton and T2 is equal to 926 Newton. Let B be the width of the belt we want to calculate, and we know that mass of the belt per unit length, that is meter length, is equal to area into length into density, which is B into, that is width into thickness into length into rho. Substituting the values we get the M is equal to 10.45 B into kilogram per meter. This is the mass per unit length. And we know that centrifugal tension is mv squared. By substituting the value we get 5805 B Newton. Maximum tension in the belt is equal to T equal to stress into area. Now plugging the values here we get B is equal to 0.122 meter, or in millimeters we get it is 122 millimeter. This is the thickness of the belt we have to calculate. For the second part of the question also we have to calculate the width of the belt. Given details are in the question, and from the same following the same steps we can calculate. The velocity V is calculated by pi dn by 60, which is equal to 23.6 meter per second, and from the power transmitted equation we can get T1 minus T2 is equal to 995 Newton. Let it be equation 1, and by solving for friction coefficient and angle of contact we get T1 by T2 is equal to 2.375. So let it be equation 2. From 1 and 2 we get T1 is equal to 1719 Newton and T2 is equal to 724 Newton, and we get the mass per length of the wire is equal to 10 B kilogram per meter, and centrifugal tension Tc is given by mv squared, which is equal to 5570 B Newton. Then next is the maximum tension in the belt is equal to stress into area, which is equal to 21,000 B Newton. So as total we get 1719 is equal to 21,000 B minus 5570 B. So we get B is equal to 114.4 millimeter. This is the width of the belt that is required. Hope you find this video is useful. Thank you.